Geometry, how's it going? Today we're going to use trigonometry and things that are lying around the house in order to measure tall things like trees or buildings. But to do that, you're going to make a clinometer. If you don't have these items, that's okay. You can watch along with me, but it's really fun. It's actually pretty cool. I've made a clinometer here. What I did was I printed off a protractor because I left all my protractors at school. I printed off a PDF of a protractor. I printed it out and I cut it out. And I taped it to some cardboard to make it stronger. That's how you spell clinometer, if you need to Google that. Anyway, I found a protractor, I printed it out, I taped it onto some cardboard. I poked a hole right in this kind of middle part. Okay, so I poked a hole right through there. I threaded a piece of string through so it's taped onto the back. And the string is tied down, so I have a weight at the end of the string. I just put some scotch tape at the end of the string. Anyway, so it has a weight, and I also have a straw that I have taped from the degree mark of 0 to 180, so it just goes right across, right down the middle of my protractor. And to use this thing, you would look at like maybe the top of a tree. You would put your eye in there, you would eyeball it, and then you would look at the protractor and see what angle you are measuring right there. Okay, so currently I am measuring about 53 degree angle. It's about at a 53 degree angle there. Anyways, you should totally make one. It's fun. It's cool. It's math. Let's see how to use this thing and calculate tall items. Hello, geometry. How are you doing? This is week 4. It is the first assignment, so it is lesson 4.1. We're going to finish off looking at the tangent ratio by applying it to a couple real-world situations in order to solve for some missing sides or missing angles. You just saw how to make a clinometer and the things that you might need to use to make a clinometer. If you have those, I highly encourage you to do it because it's pretty cool. And there may be like a fun bonus challenge question. It may be something fun to do during the quarantine. I highly suggest it. Anyway, I am going to be giving you numbers. You just need to know how to plug these into the formula and solve for missing sides. Here's your joke for today. Ha, super funny. Let's get into just a quick review and example of what the tangent ratio is again. So tangent ratios, we're looking at right triangles, and there is always going to be some sort of reference angle that we call theta, and it kind of looks like that, all right? So in this right triangle, I have my right angle here. I'm going to pick this angle to be my reference angle for now. It could be other one, but I'm just going to pick this one for now. Our tangent ratio, so we're always looking at a tangent of some angle theta. It is comparing the opposite side from this reference angle theta. So the opposite side of theta is going to be this side over here, so I'm going to label this as my opposite side to my reference angle theta. The tangent ratio is tangent theta equals opposite over the adjacent side, and here in my reference angle theta, the adjacent side is going to be one of these two sides that are adjacent to this angle, but it has to be a leg of the right triangle. So if you look at this side right here real quick, that side we know is opposite of the right angle. And we know that the side that is opposite of the right angle is always going to be called the hypotenuse. So this is called the hypotenuse. That means that this other side has to be the adjacent side. Okay, so here's my adjacent side. It is a leg of the right triangle. It's also one of the sides that makes up this reference angle theta, but it's not the hypotenuse. Okay, so tangent of theta equals opposite over adjacent. I'm going to highlight these here so we have a little color coordination going on. And I'm going to put a couple numbers to it just so we see an example. Let's say, so here's my little example over to the side. I'm going to say that I know that theta equals 32 degrees. And I also know that let's say the adjacent side is 10 feet. Okay, so that's some information that we know. I'm going to fill it into my little picture so we see it. That means that this angle is 32 degrees in this example, and my adjacent side is 10 feet. And I'm trying to find the length, right? Because I have, basically what I have is like two variables. I have two parts of my formula here, and I'm just trying to solve for the third part, right? I'm trying to solve for the opposite side. So if I plug all these numbers that I know into this formula, this little equation that I have, I could say, okay, tangent of theta, which in this case is 32 degrees, equals opposite over adjacent. Well, I don't know what the opposite side is, so I'm just going to leave that as opposite, or you could say x, right, because that's what we're solving for. Over adjacent, and the adjacent side we know is 10 feet, right? And then if I want to solve for my opposite side, then all I have to do is just multiply by 10 on both sides. So I'm going to multiply by 10, multiply by 10, so that gives me 10 times tangent of 32 degrees equals the length of my opposite side to this reference angle theta of 32 degrees. Tangent of 32 degrees, I plugged that into my calculator, making sure my calculator was in degree mode. And I got 10 times, so tangent of 32 is 0.624869. It keeps on going, dot, dot, dot. I'm just going to stop there. Equals the opposite side. And then I just have to multiply 10 to that number, which is really just essentially moving the decimal place over once, right? So 10 times 0.624869 is just going to be 6.24869. And that gives us the length of our opposite side is about 6 1/4 feet. Okay, so that was just plain like that. Here's my real world example that's going to be doing the same thing. We're going to be solving for height here. So what I did, I visited my parents a little bit ago and I asked my dad to just stand there and let me measure a couple things. So I measured the distance I was away from him and the angle. Basically what I'm going to do is I'm going to be creating a right triangle here. He does not like to be pictured in things, so we're just going to use my height real quick. We're going to use my picture, that's okay. So what I did was I said, hey, Dad, stand there and let me measure some things. So I used my clinometer. I laid on the ground, so here I laid on the ground here, and I was able to measure this angle. And I found out that this angle here was 42 degrees. And then I asked him, I said, how far away are we? We used a tape measure. And I found that from this point, I was about 75 inches away. And I said, okay, I have some sort of reference angle, right? And he is standing at, he's standing straight up, so he's standing at a 90-degree angle, right? So I have this right triangle. I have a reference angle of theta of 42 degrees, and I have a adjacent side, right? An adjacent side of this right triangle, and I'm trying to solve for this opposite side. I'm basically trying to solve for his height. So let's set up, run out of room here. Okay, let's set up our little tangent equation. I'm going to say that, well, tangent of my reference angle of 42 degrees, so tangent of 42 degrees has to be equal to, and I'm just going to write it all out, opposite over adjacent so we can see. And again, I know that this is my adjacent side, so I know that my adjacent side is 75 inches, but I'm trying to solve for my opposite side, so I'm going to leave that as just op. So tangent of 42 degrees equals opposite divided by 75 inches. And then I just have to solve for the opposite side. So I'm going to multiply by 75 on both sides. Multiply by 75 on both sides. And that gets me 75 times tangent of 42 degrees equals just the opposite, right? Because those are going to cancel each other out. Tangent of 42 degrees, I typed it into my calculator. 75 times 0.900404. It just kind of keeps going. Equals my opposite side, and then multiply those two numbers together. So 75 times the 0.900404, yada yada yada. That gives me 67.53 inches is the opposite side length. So his height should be about, just for the sake of this, I'm going to round it up to 68 inches because I know I'm probably going to be off. There's going to be a margin of error. It's measurements in the real world. And then I asked my dad, I said, how tall are you really? And he said, well, I am actually 6 feet and 2 inches. I said, okay, let me convert that all into inches. So 6 times 12 plus 2 inches, right? This is 6 times, there's 6 feet, 12 inches in a foot. So that's going to give me 72 plus 2. So he's really 74 inches tall. So, I mean, again, it's not an exact science because we're in the real world. I'm bound to make mistakes. I probably wasn't exactly at ground level. You know, my clinometer was very high tech, as you will see here in just a second. So there's going to be some room for error, but you get pretty close, which is actually pretty cool. And it'll be cool. It'll be nice to use to estimate some measurements, which we're going to do now. All right. We're going to find the height of a tree, or we're going to get pretty darn close. I'm going to pick a tree. I'm going to pick a tree to measure. And I'm going to pick this one right here. So I'm going to find how far away I am right now from the base of that tree. Okay, from this tree here, I have a spot that is marked about 100 feet away. A high-tech clinometer here. It is currently measuring at 90 degrees because I'm holding it parallel to the ground. So I'm going to angle it at the top of this tree. I'm going to look down the straw and see what angle I'm measuring. To know that I feel really weird doing this, but from my eye level right now, I'm measuring about a 40-degree angle. All right, so we just found some information about the tree that was outside, and I was measuring all this from my eye level. So this right triangle that needs to be drawn has to be measured from kind of about like the top of my head, right? So measuring from my eye level, I was about 100 feet away from the tree. So I know that this distance here that I just drew in the red line is about 100 feet. And again, from my eye level, I was looking at the top of the tree with my clinometer, and using the clinometer, it said that I was measuring 40 degrees, but you have to remember that when I was holding it parallel to the ground, it had a measure of 90 degrees. So if my change was 40 degrees, technically what I need to do is minus the 40, that measurement that I had. I'm going to minus that 40 from 90, and I'm going to get the true angle. Okay, so just trust me here. What I have to do is do 90 degrees minus the 40 degrees, and that gets me 50 degrees. So I know that this true angle here that I measured has to be 50 degrees. All right. So it's kind of backwards with the clinometer. I had to research how to use that thing. It was a new instrument. This is something that I wanted to do in class, by the way. So I'm really bummed that we didn't get to do this. Anyways, so now I have a reference angle of 50 degrees, and I have this adjacent side to my reference angle of 100 degrees, and I'm trying to find what is the height, what is the total height of this tree, right? But if I use my tangent ratio, it's only going to get me the opposite side, right? And the opposite side only runs from the top down to about right here. So to find the full length, I'm going to have to add in my height at the end, all right? But let's focus on finding how tall that green line is here, right? I should be able to find the opposite side of this right triangle. So I'm going to set up a tangent ratio or a little equation, what we've been working with. I'm going to say that the tangent of a reference angle theta equals opposite over adjacent, and I'm going to start filling in the information that I know. Well, we have tangent of a reference angle here. Again, it's 50 degrees equals opposite over, my adjacent side is 100 feet over 100 feet. I'm just going to find the tangent of 50 before I multiply anything. Tangent of 50 using degree mode on my calculator, it's going to give me 1.191753. It keeps going on, ... I'm just going to stop there. Equals opposite over 100. I'm going to multiply by 100 on both sides. Multiply by 100 on both sides. And really, that's just going to move the decimal place over twice, right? So this is going to give me 119.1753 equals my opposite side length. That means that this distance right here is 119 feet about. And then I'm asking for what's that distance so that I can add that in. Well, I'm going to have to estimate my height. I'm going to say that my height is about, so I'm going to have to add in 5.7 feet because I'm about 5'8", 5'7"-ish. All right, so I need to add 5.7 into that measurement here. So now I have 119.1753, yada, 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 plus my height of 5.7 feet, and that gives me about 124.875. I'm just going to round it to the tree is in total about 125 feet. And I didn't say this at the beginning, but I was estimating it to be around 130 to 140 feet. So I think we're pretty close in the ballpark there with 125. Again, we didn't use the proper tools. I made this out of Scotch tape and straw, but I mean, this is pretty dang cool. You can find the measurement, or you can find how tall something is just by knowing an angle and how far away you are from it. So I think this is pretty darn cool. I would love to see if you are able to make a clinometer, if you have the materials at your house and you have some trees, or you can measure your house or whatever, something tall. Maybe you want to guess a sibling's height. I would love to see a picture of your clinometer, picture of your little science experiment, your work. That would be awesome. That would be amazing. If you don't have those materials, I will also have some other problems that you can follow this process. But, and again, it's not a perfect measurement, right? Because there's going to be some room for error. I probably wasn't exactly 100 feet away, but it gets you a good idea of how tall something might be. And you know the process. You can find out how tall a tree is now. All right. I'm going to say go team. The assignment, very similar to this. We're going to be wrapping up our tangent functions. And yeah, go team.